likelihood that you'll get saturation on the checkpoint side of a target before you get saturation on the activating side of a target. And in addition to having those variables being influenced by receptor density, again, as was nicely outlined before, the question is further complicated by the affinity and the avidity characteristics of each side of the molecule toward each target being approached. And at the end of the day, this creates a picture for us where I think thinking about PK and half-life for bispecific molecules that don't have any intrinsic cytotoxic or cytostatic properties, but instead are geared toward linking or activating immune cells to tumor cells, should really be thought about from more of from a receptor occupancy perspective than from the perspective of free circulating drug as it traditionally has been for many other modalities. And so in our case, again, we're thinking about getting the drug to the places where T cells are likely to be in close proximity to tumor cells. And I think the rules there, we may not have enough data yet to say this for sure, but the rules may be slightly different again than they are for molecules with intrinsic cytostatic and cytotoxic properties, in that the penetration needs to occur at the places where tumor cells and T cells are in close proximity to one another, and generally that's at the leading edge of a tumor and in proximity to tumor vasculature, first and foremost.
That's a very interesting comment, very helpful. Wow, with so much to think about, I want to kick off the next little section on indications. Can we slip to the next slide as well, the graphic? And I'll ask Ollie to talk about what he thinks are exciting indications for bispecifics and kick this little segment off. Ollie?
Yeah, thank you, Linda. Before I go there, I wanted to provide one additional comment to what Taylor and Ezio said here, and that is that I believe personally that platforms for bispecifics also need to be supported by some element of protein engineering in the background, because all the things we're talking about, PK, PD, avidity, affinity, can all be dialed up or dialed down. ADCC being ADCC active or null can be dialed up or down. So when your platform is supported by a knowledge of structural biology, a knowledge of protein engineering, you get to explore more, you get to dream more, because even when you know your biology, it's not like we perfectly understand these biologies, we perfectly understand these tumors, and you have to be iterative. As you do your in vitro or your in vivo experiments, you should be able to take that information and further tailor your bispecific, whether it's full length or just a component of an antibody, and make it better. Otherwise, you have something that may never make it into the clinic, or once you are in the clinic, you might have some surprises that you really don't want. So the field of structural biology, the field of protein engineering goes hand in hand with the development of bispecifics, and that is something we at Zymeworks, alongside our colleagues at Macrogenics and Xencor and et cetera, have invested heavily in, because you have to understand the protein from a structure-function relationship in order to have the best chance in the clinic, as opposed to the best chance in just publishing a paper. So I just want to emphasize that for the audience, that keeping your eyes open and knowing that this is an iterative process as opposed to a straight shot to the clinic is very important. Secondly, on the indications, naturally, due to the great work that the folks at Micromet did with BITE and even our colleagues at Macrogenics with CD3 redirection, the first thought was, CD3, CD19 or CD3, CD20, which naturally lended itself to hem-onc practices. I'm pretty sure before the CD3, CD19 work, nobody ever thought that it was possible to redirect a T cell to a malignant cell. But that great innovative work made everybody's eyes open. And I remember about 15 years ago sitting at a lot of bispecific conferences with the question be, we believe bispecifics are great. We just have no idea what to do with them. Till, Blincyto came along and everybody's like, that is possible. What's happening today is a lot of preclinical work, a lot of actual clinical work is showing bispecifics could be very valuable in the context of solid tumors. For example, our own asset, ZW25, is targeting breast cancer, HER2 positive breast cancer, by combining the best of Herceptin and the best of Perjeta into one bispecific antibody where 1 + 1 is supposed to equal 5 as opposed to 2. So this shows that you can take clinically known and validated targets, combine them into one, and essentially go after anything. The only problem is most of these are sitting in the private domain or in the preclinical domain, and the greater world doesn't know about it, but it doesn't mean that the indications for bispecifics are only limited to hem-onc. I believe the future is more along the lines of multifunctionals, where, as I said, you take advantage of all elements of antibodies in really tackling a disease target and hitting it hard and hitting it fast, such that when it comes to resistant refractory relapse, we put that to bed and think about CRs as opposed to just long PFSs. I think the value of bispecifics is the ability of CR, especially bispecific ADCs, which are coming along very nicely and represent next generation antibodies where you get to have an antagonistic effect from outside of the cell, and then the bispecific antibody gets internalized, releases its payload, and destroys whatever may be left inside. Or even if it's not even a cytotoxic payload, it could be a small molecule, a targeted small molecule where it affects intercellular communication. So the future is very bright for bispecifics across multiple different indications beyond just hem-onc.
Sanket, please add to that and talk to us about how you see BiTEs and solid tumors, if you would, please.
Sure. Absolutely. And I being from Amgen and having, as a company that launched Blincyto, as others have mentioned, I couldn't agree with Ali's comments more, that the future for bispecifics and BiTEs is very bright indeed. But with that, I want to give a little bit of context to your question. As I alluded to earlier, we, over the past few years, a lot of patients have benefited from Blincyto. And in that time, Amgen has continued to tweak, optimize the platform. Half-life extension was one that I mentioned over time. And we are, in the past few years, we have now built in our early development and discovery organizations over a dozen programs, a number of which are in the clinic. And as the audience, as the panelist rightly said, a lot of questions will really only be answered in the clinic. But we have this dozen-plus set of BiTEs that are now being moved quickly into the clinic to answer some important questions about how, could a BiTE be developed for every tumor, including solid tumors. So one thing I want to say is that, the hypothesis is absolutely, and in the next 2 years, we will get a lot of data from the clinic that will answer this question about the targets, the platforms, and really which tumors are more amenable to a T-cell bispecific. So one of the key questions that we grapple with in particular when we look at solid tumors is the selectivity of the target. So expression on cancer cells, not on healthy cells, and which would allow for enough of a therapeutic window. And that's probably the main limiting step, I would say, particularly for solid tumors, finding a very clean target. There are other issues that we are looking at, such as, low antigen expression or variable expression, or even a couple of things that you mentioned before, tissue penetration, biodistribution. Those are all important questions. But I think in the context of solid tumors, really having a clean target is probably the most important one. So I'll make a couple more points really, can a BiTE be developed for every tumor type, particularly solid tumors? There are a couple more things that we would want to see in those experiments, and then the panelists